Good morning, everybody, and welcome to our webinar event. My name is Pauline Boyd, Marketing Communications Manager for Burkert Australia. We're excited to have you all with us this morning and hope the information shared is really helpful and relevant to you all. The event this morning will begin with outlining how new demands and technology enhancements is influencing automation evolution and how this looks for processing solutions. Our panellists will take you into our virtual factory, providing an overview of each significant room within the facility, as well as highlight key automation solutions that may be considered for each process. We're privileged to have Kris Anderson from Automation Mechatronics join us today to share insights on our automation project that he has faced recently. I'll now hand over to Chris Hoey, Managing Director for Burkert Australia and Regional Coach of Asia Pacific. With 30 years of experience, his enthusiasm for industry evolution and solution development is second to none. Chris will introduce you to our other panellists as well.
G'day everyone, and thank you very much. Firstly, let's introduce our presenters today. After myself will be Ryan Orbell, then handing over to John Kennedy. Ryan's our Hygienic Manager. Kennedy is our Water Segment Manager. Then we have Kris Anderson. Welcome, Kris, who'll be giving us a customer perspective of this technology. And our panellists today are Ray, who's our National Training Manager, and Nelson Chimiak is our National Engineering Manager. Okay, so let's kick off. We hear a lot of hype in every magazine article we read these days, and everyone's talking about all these different technologies and the digitization and smart factories, etc. But yeah, this is actually coming faster than we expected. It's moving upon us in quite a fast rate, and we're getting demands already from customers to start delivering some of these concepts. We find ourselves working clearly in operational technology, but the merging now with information technology is a major challenge. And whilst some in that operational technology sphere try and fight back and say this is ours, hands off information technology, we believe our challenge is actually to embrace this and make it a seamless connection, which is the best way that I think we'll be able to fully integrate the future systems. If we look at the change that we've also experienced, there's quite a large change in our automation infrastructure. We came from a system which was very layered, where we had our hierarchy of automation devices right down to the I/O in the field to the ERP system. So you can see there that the only way we could communicate was with different networks, different systems, and only to the one level above or below. So it was not an open forum communication. The new way of doing automation is everything is able to talk and communicate with everything. And there's a lot of advantages to this, and quite frankly the old networks that existed were not capable of delivering such a framework. So that brings us to the new automation infrastructure, where Ethernet is the enabler that actually has changed this capability. Ethernet can now be run right from the operator, SCADA, engineering, asset management, and even cloud-based services right down to I/O in the field. So that's a big change, and Ethernet has a lot of advantages, not to mention things like bandwidth, but also the ability on most systems to even run multiple networks over the same cable. So you could be running diagnostic information as well as synchronous information for control directly to the PLC on the same network, not having to run two different networks and different systems. So this is currently where we see the modern automation infrastructure. If we look at this in taking it back to information technology, etc., this is where the split is becoming quite clear to us. Everything happening from the PLC and access points down remains clearly in the field of operational technology. We don't see information technology sizing a control valve as an example. But on the other hand, that control valve is going to deliver diagnostic information, etc., that is going to be needed and analysed from an information technology perspective. So it's a clear division here in where it goes, but whilst we call it a division and I put a line there, this needs to be seamless. So we're going to look today mainly at the field side, the operational technology side, and we're going to look at the different options and different ways of communicating in the field. So firstly, we're going to look at remote I/O and how we can install Ethernet using remote I/O. There will always be basic devices. In other words, things like solenoid valves and like a simple pneumatic valve, etc., that you may not want to put Ethernet to. And it also just doesn't make sense. It's like delivering air satchels with a semi-trailer. It's basic devices that you can connect, and you can connect to these I/O hubs. Now, whether they be centralised or distributed, these I/O hubs are now a lot different to the I/O hubs that were there in the past. They now have the ability to talk on multiple networks, and as you see there, the examples, PROFINET, Ethernet IP, Modbus TCP, EtherCAT. These are all advanced Ethernet technologies, etc. But they also have diagnostic capabilities. You see that there's no longer LEDs and the like saying that the valve has got power. We've actually got indication of the pilot operation, indication of the field valve operation. We've got cycle counters. We've got even wire break detection and timeouts. The whole range of diagnostic information. Not going all the way down to the actual final element in the field, but at least at the I/O level. The second way to take Ethernet to the field is take it directly to the field, where we put in devices that potentially can have Ethernet directly mounted. Now, these are normally the more higher level devices, like specialty flow meters, modulating valves, positioners, electric control valves, etc. Devices are obviously of a price point and also a complexity where it actually makes sense that we can have a direct Ethernet connection in the field. You still have many limitations. Ethernet is it's a great network. We all know that. We plug it together with our computers, but it at this point doesn't carry power with it, so we have to run separate power. We also have limitations of 100 meters, and it really is a star topology. Even though most Ethernet devices have 2 ports, you're technically running a small switch in each one of those devices. So whilst we can make it look like a daisy chain, it's really a star topology. So this is where Ethernet mounts directly in the field. The next type we'll look at is when we use gateways, or also known as proxy devices. In other words, where we swap from one network to a secondary network. In other words, we go to something that actually talks at the level of the field. There are multiple sub-networks available that operate under Ethernet, and I've given you just a couple of examples here. Of course, ASSI is one of the big ones that we've known in the past, and very soon we'll have ASSI 5. Products are now starting to roll out with that. We have IO-Link, CAN-Open, Profibus, and also a sub-network that we call Bus, which is the integration of our own field devices. So there are many different networks, and there's many ways that you would use those when it makes sense. So coming back to our automation infrastructure, we see that there's different technologies and different ways we can take it to the field. We come then to the information technology part, and we say, well, depending on what we choose in the field, we can then start to analyze data and information at the other end. Now, this will be the topic of other webinars that we host, but just to give you some ideas on what we can do, we've given you some concepts here. At this stage, a lot of companies are using edge devices to actually, whether edge controller, etc., to start collecting and utilizing and analyzing diagnostic data. Now, the reason we do this, why don't we just do it in the PLC and the SCADA like we did in the past? Well, the problem is that the amount of data that we would be looking at. If we just look at something like a smart modulating valve, that device could generate up to 3 terabytes of diagnostic data in a year. Now consider you may have 100 valves on site. I don't think any PLC or SCADA system is going to be interested in trying to process and trying to manage that amount of data. So what we look at is generally a computer-based edge device that can read through that data, sort the data that we actually need, and then start running some diagnostics, etc. Because this is happening in an acyclic way. In other words, we're not scanning diagnostic data necessarily every few microseconds. We're scanning maybe at a much slower rate, depending. Things like asset management, where we collect ID number, last calibrated, etc., is not necessarily going to change even on a one-day basis. So it doesn't need to be scanned at that level. So these edge devices can sort through the data, keep that complexity out of the PLC, so the PLC maintains its speed and etc., doing what it's designed to do, and they can then report to us via mobile platforms, emails, SMS, etc., of issues, or of course back to the SCADA system as well to say to generate alarms, etc. The other way that many people are talking about is having a planned access point and then going directly to the cloud for advanced diagnostics. This will be the end goal for many people. I think when we talk about the number of different technologies and things that are available, we hear from Siemens about MindSphere, we hear about Microsoft IoT Hub, Amazon Web Services IoT Core, and IBM Watson, etc. So there's many different types, but one thing that I'm noticing very much in the field is that a lot of people are not ready to put everything up there when they don't actually know what data is of value and what data they can get the most out of. So when we come to the systems of both information technology and operational technology, it makes a lot of decisions that we need to make. So we can choose different networks, we can choose different topologies, etc. So we've got choices. So the driving decisions that will drive this are two things. Obviously the process design that we have, and secondary is the geographic layout. So these two things will make a big difference in how we actually choose what network to use and also what concept to use, which leads me on to Ryan now, who's going to talk a little bit about the different concepts of applying these different technologies in the field. So I'll hand over to you, Ryan.
Good morning to all our attendees, and I'd like to thank you for joining what is actually our first ever webinar. Hopefully, I'm hoping it will be one of many to come, but I guess as we say when we all talk about that topic of Industry 4.0 or the Industrial Internet of Things topics, we always say we have to start somewhere, so let's start. Here, I would like to introduce you to our virtual factory. We would consider this factory to be a traditional food and beverage company with a modern automation infrastructure. I would invite you, however, to use your own imagination today to adopt maybe your own production type and to consider what sort of principles or needs are around your product type that you might be manufacturing. In our virtual factory, there are a number of different rooms and types of production and processing areas. So we have the incoming town's water and pre-treatment zones where we're looking for use inside the factory. So we have water and chemical makeup areas, and these will be used later in the general production and processing rooms. We, of course, in a food and beverage plant do have a CIP room. And finally, we'll take a look at the plant utility areas. And these are going to be needed, obviously, to treat the production waste from any cleaning regimes, any washdown areas prior to discharge to the town sewer systems. I guess to ensure the safe and reliable operation of your automation processes, it's actually going to be highly likely that even a combination of different automation concepts would be considered. So whether that be electro-pneumatic valve islands are going to be housed in a centralised location, you know, potentially most likely with electrical components such as a PLC, might even be considering a distributed pneumatic valve island system which is mounted much closer to the application. This, of course, all designed generally to manage costs and cycle times. Or finally, we can also look at and consider a decentralised automation solution. And in this particular concept, we're going to use control heads that are mounted directly onto the process valves. I think it's important that all various automation concepts should always be considered as to what is actually going to be the best fit and the best approach to your application. I think it's even highly likely that you'll probably need to use a combination of automation types, and this may well depend on a number of different factors. Are you looking at a greenfield or a brownfield site? Is the particular upgrade that's under consideration a small, medium or large upgrade? There are, of course, going to be many important questions that you will need to ask yourself before deciding which path is the best path for you to finally choose to take. In the virtual factory, we can see that it's a fairly simple process to connect each of the rooms together using different and intelligent concepts. It's actually quite simple to integrate into the existing network infrastructure that is on site using one of the many different communication types. Or we can even consider to combine intelligent automation concepts where Kris spoke earlier, like using a gateway for an example. From a communication point of view inside the factory, it's really simple and economical to connect up or down into the many different field bus option types, and therefore to communicate between those room types. I'm going to hand over to John now, who's actually going to discuss some of our more familiar automation types, being centralised and distributed, before I'll come back and address the topic of decentralised a little further.
Thanks, Ryan. Hello, everyone. It's nice to be with you today. All right, so if we take a look at a couple of these different concepts, automation concepts, I'll start with centralised automation, what Bürkert referred to as centralised automation. Pneumatic technology is well known for high reliability, its high force and torque generation. So this makes it a very efficient solution to actuate valves in process control applications. So centralised automation may be the most familiar process automation concept to most people, whereby we have all the control functions and information at a central point. As can be seen in this picture, it is essentially a combination of electrical and pneumatic components installed inside a central control cabinet, generally a larger cabinet. So if we run through some of the points of centralised automation, the obvious one is everything is in one place. Concentrating all control functions in a single room or control cabinet ensures their secure placement away from disturbing influences. Centralised process control also makes it easier to maintain an overview of what is going on, and it can be extended quite easily should the need arise. Protection against corrosion and unauthorised access through lockable cabinet doors makes it ideal for harsh conditions in process environments or when maximum operational reliability is required. Isolated installation due to difficult environment, maybe a hazardous location or regular washdowns, for example. And the continuous system availability due to the hot swap function of the valve island. So the individual valves on that island can be replaced during operation should that need arise. It has a modular and customizable design as well for your individual solutions. I guess some other points to consider here are the pneumatic tube length and the size of the actuator being controlled. Additionally, the complexity of commissioning and maintenance to large distances between valve and cabinet. Also, correct labelling to determine which pilot is driving which valve need to be considered. So based on that, we'll now look at another automation concept. And this is what Bürkert referred to as distributed automation. So it's a little similar to centralised automation, but as I mentioned earlier, when considering your distance to valve and pneumatic tube lengths, etc., you may find that you need to move your pilot valves closer to the process, which will allow for a more efficient automation or speed of automation. Bürkert has run some physical tests on this point, and they showed that a standard 6mm pneumatic tube with a length of 3 to 4 metres reduces the air capacity or flow rate by 50% A tube with the length of 12 to 14 metres reduces the flow rate to 70 to 80%. So this information, along with the required speed of response for the process, helps us to determine which method of automation we might consider. Often it is one or two. These cabinets are generally smaller and can be flexibly configured to meet your needs. A number of these automation cabinets or remote valve banks could then be distributed around your plant to each zone they are automating. So if we run through some of the points of distributed automation, the obvious one to your process: lower air consumption, which involves a faster switching behaviour. High level of digital compatibility, compatible with all the common communication standards you would expect. Continuous system availability due to the hot swap valves, as we mentioned earlier, and improved commissioning maintenance times due to the smaller distances to valves. So summing up, I guess, if the plant configuration means that valves have to be close together or plant sections are to be flexibly configured, distributed automation presents an ideal solution. Okay, we're back to our virtual factory. I'd like to run you through a couple of virtual rooms with you here at the front and the back end of this plant. So as you can see, we've highlighted the pre-treatment area here. Let's take a closer look at this, and we can see there's a number of different processes involved in pre-treating the incoming town water for our food and beverage plant. This could include a reverse osmosis area and the associated pre-filtration areas required for this kind of process. Many valves could be used in each of these areas, performing different functions like, for example, backwashing and cleaning of different filters or membrane integrity testing, for example. As each area is spaced apart and some of the valve actuators being quite large, it was well suited to look at a distributed automation system. This would allow us to keep each automation cabinet closer to the valves being actuated in each location, meaning smaller pneumatic tube runs, allowing higher airflows for those bigger actuators. In this case, each cabinet could easily be connected together at each location via the preferred network on site. As all the components are inside one control cabinet, it does provide a kind of space-saving solution. So the wall or floor-mounted wall, as we can see here, valve bank helps to prevent elaborate piping. This helps you allow for minimum planning effort and reduced install and commissioning times when on site. Okay, let's take the back end now of our virtual factory, the trade waste and recycling area. Take a look at this. We can see there again could be several treatment processes involved. Based on the typically harsher environment found in an area, the standalone location that generally comes with it, this part of the plant could be well suited to a central automation concept. It allows all of the electrical components, PLC, etc., as well as the pneumatic valve banks to be located in the one place, housed away and protected from the harsh process environment. So while this area is dedicated to treating the liquid waste to a level allowing it to be acceptable for discharge to sewer, another area is dedicated to treating water to allow for storage and reuse in the facility. The water treatment processes involved here include an ion exchange skid. Many valves are needed in such a process to perform different functions, such as switching between different ion exchange vessels or regenerating the resin within the vessels. And a certain criteria was required here, such as valve position feedback, visibility of valve position, and large yet compact skid requiring valves to fit in an extremely tight space. Like each application, it's possible to use one or two different types of automation concept, but when we weigh up all of the requirements, a decentralised automation concept tended to be the best fit. The LED tops ensure that statuses are clearly visible even from a distance. The increased IP rating of the valve head also made them suitable for an environment where many particles are used. Okay, so that wraps up our view on centralised and distributed automation as the far more automation types, I guess. So I hope this has given a view as to where within a factory these applications could be used. At this point, I'd like to hand back to Ryan, who will introduce and talk to you through decentralised automation in more detail than I have here, and on a tour throughout the other rooms of that virtual factory where this type of automation really does well.
Thank you, John. I was invited to do a talk today about decentral automation because it really is a technology that I'm pretty passionate about, and I think it's an area where we as an organisation, we've had a lot of experience over the years, and in doing so we have managed to gain a lot of knowledge about what works and maybe even to an extent what might not work best for an application in a given area. I'm really thankful for having had the privilege of being involved in a number of exciting projects and with a number of different and thought-provoking applications where we have used this technology over the years. Often, I think it's fair to say though that we have had to challenge those initial thoughts or concepts about whether taking the path of even that more traditional approach was even the right concept, or should consideration be given to changing to a decentral concept. Many of those results have indeed seen some impressive savings that have amounted to many tens of thousands of dollars. This, of course, I do say is relevant and depending on the project size, of course. So it's fair to say automation in the food and beverage industry is definitely anything but a blanket solution though, because there really is no one best method. And depending on the application at your plant, there are going to be a number of different aspects that will be important to you. In decentral automation, we take the control heads and we integrate them directly into the particular process valve and actuator. In doing so, they can now function as a complete automation unit, and they contain everything that is ever going to be needed for the complete automation of these devices. Probably the leading advantage of decentralized automation is that it makes use of intelligent devices that we now take and mount directly and all the way down to the field level. Using one of the many intelligent field bus communication networks, we can now eliminate so much in wiring and cabling, and this of course will lead to many dollars that can be saved during commissioning stages. When I talk about saving money, I really am talking about savings that can amount to literally tens of thousands of dollars, all this depending on the size of the project. Taking this approach, it also means that it certainly is possible to eliminate all of the I/O cards at the PLC central level, and then in doing so, many of the termination points and of course those costly junction boxes that are mounted in the field when using one of the more traditional approaches. With these new technologies available, it's even now possible to bring the diagnostics all the way down to the field level. And this is going to mean reduced maintenance costs and overall much better asset management in the long run. I actually can recall when we first brought out the one-touch commissioning of these devices back in 2008, and it was a pretty big deal. This one-touch commissioning, it could completely stroke, test and configure the valve and feedbacks of all of these decentral devices. But now we're even talking about commissioning all of these devices from a single central point. One of the nice features about this is that it's actually very simple to expand and grow with this solution as your plant production grows. All you need to do is simply plug another device into the network or even several devices. The only limitation is actually going to be generally the capacity of the gateway. So I'm going to give an overview of rooms 3, 4, 5, 6 and 7. So in our virtual factory, we have rooms 3 and 4, which are the recipe rooms. This is where we make up the chemical and water recipes, and that of course will be used by the CIP rooms later on. In rooms 5 and 6, these are our main process and production areas, and in zone 7 we have our CIP room. Typically, and the reason I've chosen all of these particular rooms is that in all of these areas, they're generally the sort of applications where we have a large cluster of on-off process valves or even modulating control valves. And the important function here is that we can understand and we realise that all of these devices are mounted really close to each other. They're a lot of the time in washdown zones, and therefore it makes a lot more sense than housing, I guess, the pneumatics back in distributed or even centralised panels. So in the centralised solution, there's going to be that need to even have those junction boxes mounted throughout the field, and they are then going to be exposed to those washdown areas or any of the even harsh environmental conditions. But the point being that when we consider a decentral concept, this really is where the advantages of process meets automation all come together. I remember not that long ago when we used to use IP converters for controlling the volume of steam or even glycol through these control valves for all the heating and chilling circuits in the plant. But now it just makes so much more sense to use these newer technologies that are available to us. Now these positioners and PID controllers will mount directly into the process fitting out in the field. And with these PID loops, it's even possible that we can now take direct connection of sensors into the controller, whereas the traditional way is obviously to go all the way back to the PLC and the centralised panel using I/O cards. There is a possibility now that by using this direct connection method, we can eliminate the need for any of those extra input and output cards at the PLC as well. These devices also consume far less compressed air because they now utilise what's known in industry as digital technology. And this means they have no inherent compressed air consumption at steady state. Or if I was to put that in other words, I'd say when the process valve is in any state unless the valve is in motion, so when it's steady. There are several significant advantages to using a decentral automation concept. I think one of the biggest point of failures is the risk of moisture or condensate ingress. So a lot of R&D effort has gone into specifically designing devices for continued operation in wet and washdown areas. And the nice thing is it also eliminates any risk of condensate issues as well. The ability to significantly reduce tubing and cabling requirements is a massive factor that needs to be considered. So using an intelligent valve top, the decentral automation concept, it only actually requires one electrical connection and one compressed air connection. And it really leads me to say I do recall one particular project where we did the analysis of a hardwired installation versus a field bus installation or an intelligent installation. And we sat down and we calculated the need for all the termination points. And these termination points were between the PLC, the I/O cards, the field marshalling terminals and the field junction box, and all the way back to the feedback head in the field. We counted 32 termination points for every single process valve in the field. So by going to an intelligent network out in the field, you can get that 32 connections down to one connection. Also, having the automation unit directly at the source means that we now are able to achieve an increase in speed and as a result a drastic reduction in the consumption of any compressed air use. One of the lovely features, of course, is these large bright LED lights and displays, and industry loves them. I mean, we have here a visibility of 50 plus meters away, and this is a function that operators report back that they love, because at a glance they can see an open, a close, or even a fault status immediately. There is the ability now to bring advanced diagnostic functions right down to the field, and this is going to provide for much better maintenance, service information, and of course that overall asset management in the long run. There's faster commissioning with the one button push button teach function to completely stroke, test and configure all those pilot valves and feedbacks, or to commission all these devices from a central point. But having the ability to terminate sensors and control heads directly into the same intelligent network, I like to think of this example if we consider I/O link, and we completely eliminate the need for any of those field junction boxes or additional wiring. This can save many thousands of dollars during that commissioning stage. And by using that intelligent network, it's actually going to be possible to eliminate all the I/O back at the PLC, and this also means much smaller cabinets and panel housings can be used to host the master PLC. What I really love, I guess, to close on this point, is it is a completely modular and flexible system, meaning it's really simple to expand and grow with this solution as your plant production grows. I would like to now take the opportunity to welcome and introduce one of our customers, Kris Anderson from Automation Mechatronics. Kris has kindly offered to join us today, and he will share his experiences with the the installations they've had on automation solutions on some specific projects where they've used a decentralised application, and he will talk to us about what has created the best solution for all parties. Thank you.
I've been involved, I guess, or knowing of Burkert since the late 90s when I used to work at Parmalat in Bendigo and at Roval, and I've been obviously getting, been dealing with Burkert for, my days at APV, my days at Tetra Pak, and now at Automation Mechatronics. So thank you for the opportunity to share my experience. I guess I wanted to talk about my most recent experience. We had a short time frame project that a customer wanted to do, and it had the added complication, I guess, of reusing valves. They had an old site which still had perfectly reasonable valves that they could reuse, but the tops, unfortunately, the water had got into the air distribution system and had ruined the tops. So we were faced with having to replace the tops and reuse the valves, but unfortunately, in that situation, we were looking at spare parts pricing for the tops, and which basically negated the value in reusing the valves. So I approached Bürkert, and they had a solution for me in the in their tops, which I've been a big fan of for a number of years anyway. And yeah, it worked out really well. So the beauty of this was that we had multiple old style valves, we had newer style valves, and valves from multiple manufacturers, GEA, Keystone, Alfa Laval, and that sort of thing. So it ended up being a really good solution for the customer in that it was economical, and it had basically the one top for the entire job, which was good. It means that the customer benefits from a lower electrical installation, and it's extremely fast to wire these devices. It was really very good. The tops, I love the visibility of the tops. As a process engineer, you can walk around and you can know instantly what's happening with your process. You can see what valves are open, what valves are closed, what valves are pulsing, etc. So it's really good in that way. Been using these tops. They're very flexible. I guess it's indicative of the experience that I've had with Burkert. They've always been innovative and flexible with the project delivery and different things like that. So look, I would say overall it was a really good experience, and sort of a testament to, they've been working on these tops for a number of years. I remember I got involved probably early 2000s with helping some local guys adapt some tops and providing some actuators and doing all those sorts of things. So they've been working on these tops for a while, and I think they're sort of I would say they're market leading in terms of their functionality and usability in the food industry anyway. I love them. I guess that's about it from me. I hope I got across the usability of these tops, and any questions, I'm happy to answer any.
Okay, thanks, Kris. This is Kris here as well now. Yeah, thanks for that. Really appreciate your time today and to actually take us through from a customer perspective. I think this is a good example of where we have been able to utilise some of these technologies. We have got a couple of questions that have come in, not directly related, but just thinking about decentralised automation, explaining today what would be a good example of some projects you've completed. Ryan, you might want to jump in and do that one.
Sure, Christian. Yeah, dairy industry, pharmaceutical industry, food and beverage in general is where some pretty good examples of some typical applications where we've had a lot of success. If we think about actually the last slide that John Kennedy showed earlier, he spoke about some ion exchange skids, and we had some some decentralised automation where there were a lot of control heads on there. They're actually a series of skids that we built for a food and beverage company, and that's a good example of where we took Ethernet directly down to the field. So each of those control heads that we saw directly connected on the ion exchange did have Ethernet connectivity. Norco is probably a good example if I thought about one dairy application. So Norco is a dairy company cooperative in northern New South Wales with a site also on the Gold Coast and down on the Central Coast. And in the last 2 years we did a pretty big upgrade at Norco where they have over probably now 550 to 600 heads, and we're just doing another upgrade with them now as we speak. But I guess one close to my heart is AstraZeneca, so a pharmaceutical company. That actually is probably a really good example to mention. That is one particular customer that was down the path of a traditional automation concept where they will have used to date or had used to date pneumatic valve islands and panels, and as a result what they did is, or we went in there and presented what the advantages and benefits would be to integrate a control head directly into the process valve. And I would say now we have well over 1,000 plus heads that we've put onto that site, potentially even more than 1,500 heads. So yeah, there'd probably be a good couple of examples of where we have used them. So they can be from little skid examples right up to tying together heads on at AstraZeneca where you've got water for injection in the water room. We had clean steam in another room, and then we had all the clean suites where production takes place, and we're able to tie all those rooms together where we speak about a higher network at the top level, and then we came down through a gateway to some more basic level field bus that would work for what the application really needed.
Thanks, Ryan. Okay, is Burkert ready for Industry 4.0 and or IoT? I might hand over to Nelson on that one, who's our engineering manager I introduced earlier. Nelson, do you want to answer that?
Yeah, so I think the simple answer is absolutely we are ready as Burkert for Industry 4.0 and IoT. We have a number of options in terms of how we actually do extract our data from the field level, as you've seen there, from our devices at the device level right up to the top end, be it your ERP system, be it your SAP system, whatever you guys are using, and everywhere in between as well. So how do we actually do that? Well, it's a good question. There's many different ways we can actually do that, and it all really depends on what's important to you and your process. So we have a couple of examples, for instance, where we take a look at some of our control valves in the field, and we want to look at diagnostics data, and we want to email alert to operator's phone when we've actually gone and gone over our cycle limit, or we've gone over temperature. And yeah, we can actually just do simple information and alarming directly to your phone or to your email system, whatever you're using. But then we take a look at other more complex installations, and then we can do a whole lot of trending data, and we can do a collaboration of all that data that's in the field and take it up to any of your other systems. So I think there's really not one simple way of doing this, or are we sort of ready for this? But the answer is absolutely, Burkert are ready, and yeah, we can solve one of your problems that you have for your issues in your field today. So the answer is yes.
Okay, thanks Nelson. Is there any more, Pauline? What's happening with ASSI diagnostics, etc.? So I might grab that one myself. ASSI's probably been the dominant bus for a lot of these applications in the past, and we have got a new specification with ASSI 5. I could talk probably about it for a long time, but to give you a short answer, there is the new standard actually is based on the old standard as far as it uses the same cable, though it's a lot more advanced. It does do diagnostics. It's up to 96 devices, etc. And you have got the ability to be backward compatible. So in other words, you can actually set up a new ASCII 5 network and run ASCII 3 devices. And as I said, the new device will be able to communicate directly with Ethernet like the old one did, of course, but it's going to be able to deliver a lot more information. It is in its early stages. There's probably only about 2 or 3 products available globally right now, but the standards are locked down, and I think we're going to see in the next 12 months quite a lot, Burkert included, releasing ASCII 5 compatible devices. One of the really nice things they've even got is a block under construction where you can link ASCII 5 to IO-Link as well, because IO-Link is another one that we see a lot of most recently in the market, which has mainly come from factory automation, but it is, because of impatience, taking a little bit the place of ASCII in this process market. But both of those are the two, let's just say gateway networks to watch in the future. Okay, and we've got one more question has come in. Kris mentioned a number of different brands on his project site. Is there an interest from customers to go down this road, and if yes, what value could be expected? Yeah, Kris, if you could maybe handle that, it would be better.
Yeah, sure. What our customers have seen is, I guess, a consolidation of spares in terms of, one top will do a lot of valves. There's a few small exceptions, but most, I would say 95% of valves are done, can be done with the Bürkert. Ryan might be able to correct me on that if I'm wrong, but in my experience so far, I've only had a couple. And really, it's just economically, it's quite good from a operations point of view. So operationally, it's quite good that way. A lot of plants have a lot of different valves. So even if you sort of were moving piecemeal to this top, you can do that. It's also available in multiple technologies, which is good. So, look, I think customers, mainly the spares and the flexibility and the economy is what they're sort of looking at with these tops, I would say.
Okay, thanks, Kris. And even from my own perspective, I was in Japan last week with a meeting with Suntory, and they had probably the last 10 plus years of plant developments, etc., probably even longer, where they've got a number of different projects by a number of different valve companies, and they're looking at moving towards digitization. And the Burkert solution for them is ideal, because they can have one head across all sorts of different legacy type valves that they have on site, and they can incorporate the lot into a single technology. And in their instance over there, it will be IO-Link, and they're looking at many thousands of heads. So it gives them a lot of flexibility when they have those high quantities. Okay, so just in conclusion, we've sort of demonstrated today about the different challenges we face, both with networks and also with different ways that we should design our automation infrastructure. And we can't probably miss the salesy part you all expected, but Burkert is the ideal partner to support your journey into plant modernisation. And I think this is because we've got the hardware competence. I mean, we invented control tops and the like. We also invented valve manifolds, believe it or not, and the DIN plug. So we are innovators in the market. So we've always had advanced product technologies. We are open with all of the different networks, and there's plenty of support available from local and both international teams. So no matter what project you're working on, Burkert is both local and capable of supporting you in that. Thank you very much, everyone, for your time. Firstly, I thank my own team for putting this together. That's a great job and certainly a good kick-off WebEx. And yeah, to Kris especially for joining us from the customer perspective, and that's giving us your time. That's really really appreciated. And then to all of the attendees, thanks for joining us, and hopefully you will share these webinars. We will make them available, and as Pauline said, there'll be a short survey so we can do it better next time, so I'm sure there's room for improvement. So thank you all for your time. We will sign off. Thank you very much.